Ma'am, I'm not able to like present the, yes, now it's done. Okay, okay.
Is
Thank
it
you.
the right page? Right slide?
Yes, it's the right page, but I'm not able to move to the next page. I don't know
Then
why.
you
Just say next.
okay.
She will
Just
take.
tell me.
She
Just
will
tell
take
me
it.
next.
Okay, okay, okay. Um, so my topic is like the AI-driven multi-social sensing framework for precision agriculture, and these are my contents. Uh, Ma'am, next. Yeah. First, we'll introduce the topic, then we'll do the review of the literature, then methodology, implementation, results in discussion, and at last, we'll jump to the conclusion. Uh, Ma'am, next. Next. Hello. Yeah. So, the, this is, yeah. This is the global agriculture faces many critical challenges nowadays, like resource efficiency requirements, environmental sustainability concern, and trading farming practices are also there, like uniform resource distribution, significant efficiencies in water, energy uses, and there's a need for precision agriculture solutions with sophisticated integration. Ma'am, next. There are some potential impacts of AgriSense AI, like they support sustainable farming practices, they optimize resource allocation, uh, and some frameworks are also there, like leverage is AI and IoT technologies, Internet of Things, enable data-driven farming decisions is also there, and it also provides the real-time insights. So these are like the comprehensive frameworks and the potential impacts. And next, yeah. So our resources basically advances the state of art, like novel multi-modal sensing architecture, adaptive deep learning model, experimental validation, so scalable IoT infrastructure, and there are some things like that combines environmental, spectral, and visual data, creates comprehensive data farm twins, and it demonstrates improvement in accuracy over time. Real-time predictions for crop health is also there, and there are some tested experimental validation across different crop types and environments, and there are significant improvements in resource efficiency and yield also. Ma'am, next. Mm, So these are the recent advances in agriculture technologies, like uh, Avile Toledo and Kumar ETL. So these all solutions focus on single aspects rather than providing holistic approaches, um, like Wong et al. Advances the deep learning
Wrong
for
et al.
crop disease. Hello, ma'am.
Please
Next.
continue. Next slide, please.
Hello. Yeah. So there are some remaining challenges also, like integration complexity, interpretation difficulties, high computational requirements, and high implementation costs, limited adoption among traditional farming communities, and there are some high implementation costs also, and um, there are some lack of real-time adaptive capabilities also. Ma'am, next. There are some multimodal sensing architecture Also four there are four, basically the four most primary components of multimodal sensing architecture, like weather app integration, environmental monitoring stations, spectral imaging systems, and soil moisture sensor network. uh, Soil moisture sensor network basically adapt the sampling strategy, and temperature compensation is there, capacitive sensors at 10 centimeter, 30 centimeter, 50 centimeter depths there. And like in environmental monitoring stations, we have like temperature to 0.2 degrees Celsius accuracy, and humidity 1.5% accuracy, solar radiation 3% accuracy, and wind speed or wind direction is zero point 0.5 meter per second. And in weather data integration, we have API connections to meteorological services. In spectral imaging systems, we have multispectral like 6 bands, hyperspectral to 400 to 2500 nanometer range, some drone mounted and fixed positions also there. Uh, Ma'am, next. There are some deep learning engine. If we'll talk about that, then like hybrid architecture combining is the more in which like bidirectional LSTM network for temporal data is like 256 hidden units, and it captures short-term fluctuations and long-term trends. And it is modified RESNET50 for image processing, like pre-trained on agricultural imagery, 89.2% accuracy in identifying early stage nutrient deficiencies is there, fine-tuned for specific crop types. And it like 3D CNN for multispectral data, or 3D CNN for hyperspectral data. It processes spatial and spectral dimensions simultaneously. Ma'am, next. So like in cross-model data fusion, we have the cross-model data fusions basically maintains robust performance even with degraded data or even with missing data also. And it curriculum learning strategy for model training. It reduces the training time by 37%, and it has improved cohesion stability, and it adaptively weight contribution of each sensing modality, like and context and reliability based weighting is also there weighing. um, so the formula of fusion process is there, like I is for fused output, WI is for adaptive weight, FI is for feature expectation, and XI is for input from modality. Ma'am, next. So there are three types of
Um, you're not audible. We can't hear you.
like there are three tier architecture for IoT infrastructure and
Okay,
system
now we can
integration.
hear you. Please go ahead.
Okay. Yeah. So like the three-tier architecture in IoT infrastructure and system integration are like sensing nodes, edge computing layer, cloud platform. And in cloud platform, we have digital twin implementation, microservices architecture on Kubernetes, and time series databases like InfluxDB, or spatial database like PostGIS. And in sensing nodes, we have IP67 related weatherproof enclosures, dynamic power management like 43% extended operational life, solar powered with battery backup is also there. And in edge computing layer, we have NVIDIA Jetson nano processors, and 73% of computational tasks perform at the edge. And like critical decisions is I200 MS legacy. Yeah. The user interface and integration, we have equipment in equipment integration, we have standardized API layer, support for common protocols, ISOBUS, NMEA, and 64% reduction in setup time is also there. And adapter modules are for proprietary systems are also there. And in user interface layer, we have role-specific dashboards. System usability score is very impressive. It's 84.6. Industry average is quite good also, 68.2. And progressive disclosure principles is there. And visualization techniques are there, like some of the awesome visualizations techniques like temporal trend analysis, geospatial heat maps, and augmented reality overlays, and some role specific dashboards as I mentioned. Ma'am, next.
Sorry, sir, you have 2 minutes left.
Okay. Ma'am, next. Yeah, the deployment environmental in we have hardware deployment, soil moistures probes, multispectral imaging, fixed imaging, and edge computing, and system reliability. And implementation across the three distinct agriculture environments are also there, like 50 hectare vegetable operations, which is semi-arid in which is available in semi-arid conditions, and 75 hectare vineyard in Mediterranean climate, and 120 hectare wheat farm in different temperature conditions. Ma'am, next. So this is the second page of like the our implementation page, and it is the software implementation. We have software stack of like influx the db for time series sensor data storage, react native version 0.68.1 for mobile interfaces, and node.js is also there for backend services, and tensorflow for deep learning components. So this is like one of the best softwares we have. And like crop specific optimizations is there, like vegetables, vineyard, wheat, and phase deployment approach is basically monitoring, then advisory, then semi-automated operations. Yeah, next ma'am. Next. Yeah, in results and discussion, we have like performance results like water consumption, crop yield, 100% traditional, fertilizer uses is 100%, and there's some improvements as you can see in the PPT. Ma'am, next page. Uh, this is the detailed performance analysis and results and discussion topic. So the water consumption is reduces from like a huge amount to 27.3%. The greatest savings is during mid-season growth is 32.4%. For fertilizer usage is also there, 35.2% reduction across all crops. That is really impressive. Crop yield is also there. Average increase of 23.1% is there. Wheat is 22.4. Vegetables are 27.8%, and disease prediction is also it gives the accuracy of 89.4%. Next. This is the comparative performance throughout the traditional IoT, single PA, AgriSense. As you can see, like purple is water usage, green is crop yield, orange is fertilizer usage, and red is disease accuracy. This is the metric value. And ma'am, next. Uh, so in system reliability and XAI impact, we have temporal stability, adaptive learning, demonstrated progressive is there, and 99.7% uptime for critical function is there. And there are some explainable AI concepts, components also, like transparency, increased trust sources from 61% to 87%. That's a massive jump. And confidence in automated decisions, 79% after 6 months is basically there. Farmer satisfaction is 87% out of 100% with system recommendations. Ma'am, next. In economic analysis, as we can see, like there are some analysis of sensitivity, like system economics most influenced by local labor cost, crop market value, and some optimal deployment scenarios are also there, like high value crop production, regions with high labor cost, and some return of investments is there, like average return of investment period 18.7 months, vegetable operation 13.5 months, and wheat farm is 23.6 months. And this is compared to industry range, which industry average, which is 30 to 36 months. Ma'am, next. Next. So there are some key achievements also, like effective balancing of computational requirements with connectivity constraints, like 73% of processing tasks at the edge, and addressed fundamental limitations identified in previous researches, like environmental variability challenges, system transparency, sensor reliability issues, demonstrated substantial improvements are also there, like 27% reduction in water usage, and 35% decrease fertilizer application also, and 23% improvement in the quality of crop yield. That, and ma'am, next. Next. Some future research directions we have to look in the future, like enhanced digital twin capabilities, additional sensing modalities, federated learning approaches, integration of satellite remote sensing data, that is very important, like extended coverage of large scale ops, predictive analysis for long-term planning, root zone imaging, and data privacy preservation. Ma'am, next. Um, Next. So the final thoughts are like, which combines technical innovation with practical usability considerations, and positions agriculture technology on the path towards agriculture 5.0, and it contributes to both productivity and as well as environmental sustainability in global food production and economy. Viability's return of investment type 2 years suggests strong potential for widespread adoption. That is a very good sign for future for this thing. And AgriSense AI also demonstrates the potential of integrated artificial intelligence and Internet of Things approaches in agriculture. And it, yeah, thank you, ma'am.
Thank
So I
you.
have one question.
Okay, go on.
You have this is only paperwork, or you have any other real models?
We
Can you, hello?
Yeah, it's a real model. Do you have any real models, or this is only paperwork?
No, we have real models, but right now, like I
It's
have this
working?
only. Uh, Hello,
Now it's
am I
working now?
audible?
Working condition?
Yeah, yeah. Hello.
Huh?
No, not in work. Like it is basically the vision to the future as of now. Like there are some models like,
Future.
huh?
The future is depends
Hello.
upon the present only, na. But if you have
Yes,
any
yes.
model, real model means you can get the data and everything is clear. Then it will move on that agriculture. Hmm? Anyway, you try to do
Yeah.
some real model. Okay.
Okay.
Hello.
uh,
Hello.
do you have our voice, Mr. Rajan Khan?
Anyway, it's a good idea. Then you can proceed with the real models.
Okay. Are you done with this presentation right now? Since you have two papers, this one was your first, and you also have the other two. So if you want to, you can have a rest for a short time. We will have another presentation, and then you can start again for your another presentation if you want to. Let us know. You can write in the chat box